So we heard this morning about data and data being so important. I think we'll all agree that data is transforming our world, and the way that we can use and put that data to work for us is really important. Biological systems are very data rich. That power of sequence information, of genetic sequence information, it is data. And that technology has so transformed over the last couple of decades. That's changed the risks, but it's also changed the opportunities for us as well. So we're now at a position where we have opportunities to make choices the way we take this technology forward and the way we implement it in our communities and use this for good in our country as well, and good in our world. So maybe I should tell you, as I said, massive advances. Maybe tell you a little bit about the work I do as a scientist. Now, I suspect that you've all heard of penicillin. Most people have heard of penicillin. I suspect you've all heard of the discovery of penicillin as well. The serendipitous discovery, leaving your dish, your petri dish, with agar on it, growing on the side of a bench with an open window. MPI would have us, would close us down if we did this now, and getting the zone around the fungal growth, which showed that a fungus was producing a compound that could inhibit bacteria. And we know how that discovery has transformed our world. Well, my research actually looks at how certain fungi can make really very complex but very valuable bioinsecticides. Now, the fungus that we're interested in that makes those bioinsecticides does not grow fast, does not grow in the light. Takes 3 weeks. If we put it in the dark, we pull it out and we pray that we can see some. It is not evolved for our purposes to make that bioinsecticide. So what we have done is reprogrammed another organism, another fungus, in order to be able to grow that compound at scale. And that's the kind of techniques that we can now harness through the changes in biology. I was thinking back, and the work that we've been doing with this bioinsecticide has been going for about 10 years now. And 10 years ago, when we first sequenced the genome of the fungus we were after, when we first went to read the sequence to find out the genetic code which makes that compound, it cost us $10,000, took months and months and months to get that sequence information back. Now we send it away overseas and $100, get it back within a few days, that kind of sequence. So the ability, the techniques that we have at our fingertips now to be able to read sequence and know what we've done in terms of sequence change have enormously advanced in the last decade or so. And of course, many of you may have heard about CRISPR-Cas as well. Precision techniques to alter, to put in genes precisely. That ability to put them in, that ability to read, that really has transformed our world. So really, I'm looking forward to opportunities where, and as I said, the opportunity to hear from colleagues about all of their ambitions about genetic technologies in the medical space. CAR T-cell therapy where we're using patient cells, reprogramming them so they can fight their own cancers with their own cells. That is important technology for us to develop. It's important technology for us to develop for our people. And we've got changes potentially in agricultural space, which are exciting, new forages and abilities to deal with climate change as well. And we also have advances such as the biomanufacturing advances that I was talking about within my work as well. So I do believe we are at a crossroads where we now have the precision and the tools to understand that molecular data and to use that molecular data, take it forward in a way that manages the risks of those procedures in a way that is appropriate for our communities. And I'm looking forward to talking about it with these guys.
Thanks for that framing. You can see why the guys wanted to make sure that Emily set up the framing of this. David, let's move.
Sure. So I'm Dave. I do climate stuff, so I'm a bit of an interloper in the genetic technology space, but I also look at things like microplastics in the environment, been thinking about those recently, and the way that I'm co-author on a paper looking at rocket launches and destruction of ozone, so a 21st century ozone problem. And generically across this space of new technologies, you have this question of identifying and understanding risks that you haven't faced before because you're creating new products. And so microplastics, people are beginning to understand the scale of that problem. And the ozone destruction thing, well, we'll see how that all plays out. But the challenge, I think, for environmental scientists is to figure out, is to keep pace with these technologies and understand what a reasonable understanding of the emergence of potential new risks are. And clearly with genes, as opposed to rocket launches, one of the distinctive features of genes is the fact that they're like recipes. They perpetuate themselves, replicate themselves and perpetuate themselves in some situations. And you can have things like the Columbian Exchange, where when Columbus first went to the Americas, there was this massive outbreak of what we would now term invasive species. And of course, it was a runaway phenomenon because of the self-replicating nature of the thing, which is different from something like CO2 burning in the atmosphere, where you have to burn each individual unit. And I think the question, the challenge for environmental scientists and for the world like the regulators who try and regulate these things, such as climate negotiators and ozone negotiators, is to understand what new risks might emerge as technology advances, and what a reasonable regulatory regime might be to deal with it, that's realistic, it takes into account all the things you'd want to take into account, especially feasibility, so that you're not killing innovation, because a lot of the innovations that Emily's talking about are really vital. The CAR T one in particular will save lives. I have a horse in that race. These are important things, and the question is, how do we keep our scientific understanding of the spillover effects, the negative externalities, if you like that kind of language, how we keep abreast of those, and how we, in as lightweight a way as possible without killing the potential for innovation, how we can wrap those risks and prevent them from emerging in a way that the costs outweigh the benefits, if you like that sort of language. That's all I want to say by way of introduction, I think.
Thanks, Dave. And it won't be the first time this pun has been used, but I think you've framed that risk thing very well. Because if we look at genetic technologies, when you think about the promulgation of regulation, it's generally in response to some accident. The first regulations that came in, I think, were in the 19th century when the Industrial Revolution was going and boilers blew up. And so regulation around boilers was some of that first regulation. And for genetic technologies, it's one of the first technologies that has actually had heavy regulation before there's actually been any real issues. And I think we're now looking 20, 30, even 40 years on and saying, well, have we overcooked that? So let's just put gene technologies in context about what do gene technologies do in our lives now. Emily touched on it, but we've got 250,000 diabetics in New Zealand who use genetically modified insulin and have done since the mid-1980s. Around the world, genetically modified crops have been used since 1996, and now there's more than 27 countries with 16 million farmers growing more than 200 million hectares of genetically modified crops around the world. And those farmers who are able to use them, where the technology is available, where the regulation is available, the uptake is about 90% of farmers, or in excess of 90% of farmers actually taking that technology up. It's extremely popular with farmers. If we think about what's going on now in medicine, and again, Emily did touch on it, CAR T-cell therapy, but even now in New Zealand, we've got not just insulin, but we've got products like Keytruda, which always amuses me that the Greens jump up and down about genetic modification, but Keytruda is a genetically modified drug, and they jump up and down about more funding for it. I like that irony. But there's a a couple of dozen drugs in New Zealand that are the result of genetic modification. The COVID vaccine that we had is a result of using genetic technologies to produce that vaccine. It didn't mean we were genetically modified, but to make that product required genetic modification to do that. So we're and also, if I just add in the food industry, we've got cheeses which are made using genetically modified enzymes. We've got beer that uses genetic technologies to improve the production of beer, and we import genetically modified feed for our animals, particularly in the pig and poultry industries, but also in our livestock industries as well. So there are things going on at the moment that surround us in terms of what we can do. Emily didn't mention it because she's donkey deep on the government side of regulation, so we'll allow her not to say anything about that. But I'm not, so I can. And that is, you may well be aware that right now the government, or in December, the government put in the bill to reform genetic technologies, the gene technologies bill. And that's going to change the way that we look at gene technologies and hopefully lift the apparent moratorium, the de facto moratorium that we've got at the moment. Because in fact, at the moment, we don't have a moratorium. We can do these things, but it's just that, and going back to Sir Brian Roche's comments, we've got a system that is so risk averse that actually nobody can do anything. So we want to try and move forward on that. So the question comes, I guess, how do we do that? How do we make it better? And the new regulatory system is around a risk-tiered system. So those things that are not risky or have very low risk get a very light touch in terms of regulation, and those things that are more risky are going to have more scrutiny. When it comes to agriculture, the question is really going to be how do we allow those systems to actually work together? How do we allow a system where some farmers want to use genetic modification or gene technologies, and how do farmers who don't want to use it, want to avoid it, and still stay in their selected markets? How do they do that? And I think if we look around the world and look at the sort of systems that governments have put in to try and cope with that, there have been two real approaches. One approach is to put in heavy regulation, traceability, lots of box checking to make sure everyone knows exactly what's going on, and moving the dial in terms of liability onto the people who are developing those technologies and using those technologies. And at the other end of the spectrum, you've got countries who have said, well, this is not an area for governments to be involved in terms of we can check for safety, but in terms of how the market's going to work, we're going to leave the market to do the market things that markets actually do best. And if you look around the world, those countries that are not using genetic modification, perhaps like in Europe, have very heavily government regulation around the use and coexistence in genetic modification. Those countries that are actually using genetic modification in their agricultural systems are those countries that have said, no, the market, farmers can look after each other, and the markets can look after each other. And those countries are like Australia, whose rules we're sort of copying, and the US. So and how do you make that work? I think there are a couple of ways that you make those sort of systems work. One is that you build intolerance into the system so that you don't have 1 grain of pollen going across the fence that's genetically modified and that immediately deregisters the person next to you. There are tolerance levels that are allowed in the market. That's one way of doing it. The other way is around the use of precision technologies, the CRISPR-Cas9 type of technologies, where you're actually just editing one letter or a few letters at a time. So to just give you a description about genetic modification, if the gene is a book, then genetic modification, if you've got a book on mountaineering, it's like taking a pamphlet on surfing and shoving it randomly in between the pages. And that's what traditional genetic modification was like. And if you think about gene editing, it's like taking your word processor and changing the exact letter and the exact word and the exact page that you want to have the exact outcome that you want. And so the difficulty with that is that it's very hard to tell if you've actually done that through a natural process, it just happens spontaneously, or you've directed it. And so what countries are starting to do is to deregulate that aspect of gene technologies, because they know they're not going to be able to have an effective regulatory system anyway. And they're looking at the risk and saying, well, what is the risk of doing this versus the risk of doing it naturally, of using gene technologies versus naturally? And if those risks are the same, why would you regulate one and not regulate the other? So I think that's where the conversation is actually going to be over the next 4 or 5 months as this bill starts to move its way through Parliament, and submissions close on the 17th of February, that's next Monday. But I think that's where the conversation is actually going to be. Where do we want that control to actually land? Do we want, as Sir Brian Roche said, the land of opportunity, or do we want the land of risk aversion?
Thank you very much. And a lot of the questions that are coming through are on regulation, of course. It's very much top in people's minds. Some of the questions that have come through, of course, have been partially answered. So let me try to break them down into a few different pieces, and you can choose, particularly Emily, that's right in the thick of it, which parts you want to comment on and which parts you don't. It would be good to talk more about the potential economic benefits of reform in this sector. So we've got questions coming through on what are the potential economic benefits. We'll move on a little bit later on to some of the risks. But if maybe each of you would like to make a few comments on the potential economic benefits of this sort of reform. Do you want to start?
Well, I'm happy to talk a little bit about with respect to my work and some of the things that I'm aware of. I mean, that is really changing. I mean, we have a choice about how we get hold of fine chemicals for pharmaceuticals or for insecticidal uses, animal health and other uses as well. We have a choice, and to some extent that is the old process of what we can manufacture using chemical plants, usually offshore. Or we have an ability to harness the power of biology. Huge investment in, if you look in the States in particular, into what they generally term engineering biology or synthetic biology, though people aren't so keen on that term now. They're much more keen on engineering biology. You know, huge advances. There have been large startups going in with, you know, eye-watering when you're trying to do a capital raise in your own startup and you look at the size of their capital raises, you think, yes, we definitely need more investment opportunities in New Zealand. You know, 50 million plus just for discovery stuff of capital raise, because they know the power of these compounds to transform in terms of therapeutics, to utilise some of the solutions nature has made to replicate, to utilise those solutions for being able to manufacture them. So there's certainly, the size of the market opportunities are really, really large. Quantifying exactly how much New Zealand could get or how much and what is the likelihood of that outcome is a much harder ask. And so we do tie ourselves up in knots, in my view, a little bit, with worrying that we must quantify that benefit, must do that before we're even prepared to start. And that not being prepared to start, even in the safety of containment, often, even in the safety where it's controlled and, like I said, inspected by MPI, and I wouldn't have the opportunity to find something like penicillin because they'd make sure I couldn't. You know, even in those circumstances, we get scared to start because we don't know that we will definitely get that outcome. Now that is not chasing opportunity. That is not using our best and brightest, the people I have had the privilege to train, and putting them to work for the purposes of transforming our economy and diversifying our economy. I think we need to embrace that opportunity. Yes, understand that. That to me is an investment decision, not a regulatory decision, that size of benefits.
Although they're related, of course, aren't they, the regulations and the investment?
In the case of methane vaccines and what have you, and doing things with sheep, fiddling with the genes or selective breeding, ideally they lead to the same outcome, which is reduction in methane from ruminants. And in that case, the benefits could have all sorts of shapes, but the most direct one is reducing the amount of warming that New Zealand already causes. So so if you had a sheep, or a general ruminant that reduced the methane we produce by I don't know 20%, that would reduce New Zealand's contribution to warming by about 10% all up. And it would be a hell of a lot cheaper, I presume, than spending $24 billion on trees overseas, which masks the warming that we produce but doesn't actually do anything to reduce it. So not only could it have substantial environmental benefits and economic benefits, assuming you can then sell this technology overseas, it would also prevent policy pathologies that we're currently heading towards, like a train on with a bridge out up ahead. So the benefits could have lots of different shapes: environmental, social, and economic.
Yeah, so if you think about, try and think about the economic benefits in a sort of global New Zealand sense, I think you get absolutely nowhere. And I think that was proved by the NZIER Organics New Zealand study that they did in a very hurried fashion late last year, where they said that if New Zealand took up, if this bill went through and New Zealand took up gene technologies, that cost to the New Zealand economy would be $10 to $20 billion. Now, you're mostly economists as far as I know, but so I'm a bit out of my depth here. But my understanding is that what that study did was they said, let's look at some premiums of a couple of New Zealand products, 20% or whatever. Let's apply that across all New Zealand exports. And then if gene technologies come in, let's cancel all those, all that premium, and that's the $10 to $20 billion of losses that they calculated to come up with. A beggar's belief, in my view, why NZIER would have put their name to this study. Alternatively, they could have actually looked at the Impossible Burger, which was proudly used genetic modification, but used fewer resources and touted their benefit as having using fewer resources, which had a 50% premium. So let's just do the same exercise in economic study and put it that way around. And instead of losing $10 to $20 billion, we're actually missing out on a environmental premium of let's say $40 to $50 billion. Neither of those studies make any sense, but it does just show that it's just really difficult to say, is there going to be an economic benefit or isn't there? But if you start to look at the individual process of the individual applications, then as Dave has pointed out in terms of agriculture, or Emily's pointed out, we will make gains in individual uses of this gene technology. And that's where I think there's going to be a big difference. But who should make the decision to do that? In my view, that's up to the users, up to the developers. Nobody's going to develop a gene technology that's not going to have some economic benefit in one way or another. And the market's not going to buy products that don't have utility and some tangible and intangible benefits for them. So I think that's something that the market will sort out. If this technology has no economic benefit, then nobody's going to be using it. And I think experience overseas shows that that's not the case.
So lots of potential benefits, pretty hard to quantify. It's a little bit like the AI, isn't it? You know, we know it's happening, but it's difficult to be sure exactly which path it's going to take. Let's move a little bit more towards the risks. Let me start with a very specific question that's come through, but then broaden it out to the risks. The specific question is, are there any modern real-world examples of escaped gene technology causing environmental harms? So if any of our panellists have got an example they'd like to offer an escaped gene technology that caused environmental harms, if you have an example, but then let's also give our panellists the opportunity to talk more generally about how do we manage the risks, particularly in this context of the potential change in New Zealand's regulatory environment in this area. Now, who would like to start on this one?
I can't think of one. Can you think of anything?
I mean, it depends on how you discern harm. And I mean, if you think of what's happened in New Zealand, for example, where there have been breaches of strict containment rules, the answer is categorically there has been no harm.
Yeah.
And I think that this is one of the real problems that we have, is that we're boxing a little bit at shadows,
Yeah.
and a breach of a really strict containment requirement doesn't equal harm, and we really need to be thinking in terms of the regulations we put in. How do we stop harm? For example, the regulations around field trials require that you have to remove all flowering structures, which if you're doing a grass project is completely impossible. The question they really should be asking is this field trial going to produce a self-sustaining population, and is that population going to cause harm?
We also, I think it would be a mistake to focus just on this idea of genes escaping, given what we know about biosecurity generally, that all the examples I can think of runaway gene puts are wasps and ants and horrible
Things that have been brought
cats,
in.
stoats.
Yeah,
It would be terribly unglamorous, but actually it would pay to think about those things as a package rather than pick narrowly on I'm scared of grass seeds versus, you know, the giant Asian hornet, for instance, which is making its way across Western Europe and is a particularly nasty beast.
Yeah.
So I think there's a danger of obsessing about modern...
That the gene technology itself,
Yes,
you know, there are biological risks and biosecurity risks, and we...
Probably want to think about them.
The National Academy of Sciences in the USA did a 1,000-page report on genetic modification maybe 5 years ago, and didn't identify any examples of environmental harm or even a headache in people who were, you know, we're all eating genetically modified crops that could be attributed to genetic modification. Are there harms that can happen? Yes, because there are harms that can happen when we do natural breeding. So it's a sort of false dichotomy to think that there's just harm using genetic modification or not when you're just using natural processes. There's risk in all of these things, and so we've got to balance those risks. So it's a difficult question to answer.
We also have to, I think, scientifically be pretty dynamic about understanding where those risks might emerge. So the microplastics, as we invent all sorts of new products and new materials, they will all have, potentially, you've got to look at them all, and that's where, as we think about, like you were talking about the not 1 grain of pollen, but a particular threshold, you want to keep the variables you are considering pretty dynamic and have a way of updating that in light of the latest science so that you can keep track of these things.
And I think that is one of the huge challenges, having a regulatory system which is nimble enough to deal with the science which is moving on and changing, but not so locked down that people can't manoeuvre on that as well. Yeah.
And let's maybe talk a little bit more about that, how you think about the regulatory system, Emily. So we need it nimble enough, but I mean, regulations are not known for being nimble. You know, the horse is bolted is something that often comes to mind when we're thinking about modern regulation. not just in this area, but all sorts of different areas,
Yeah.
IP, all sorts of different
Indeed,
areas.
indeed.
But do you have I guess, a framework in your mind for how we would think about developing good regulations that achieves what we want
It's
without
been-
exposing?
yeah. It's been really interesting considering the process and thinking about what it is. I mean, I'm a strong believer in making sure that you're clear why you're regulating. What are you regulating to protect for? And so making sure your purpose of regulation is really, really well defined, and the bill which is before Parliament at the moment, the purpose of that bill is to protect human health and the environment from the risks of gene technology. And so it is quite simple. Now, there is a lot of people, I'm sure, and I've heard some of it, and I'm sure I'll hear more, who want it to deal with many, many other things. And there are many these other things that they want regulation to deal with are not... I'm not trying to invalidate them. There really are some important issues there. But in my view, you get a cumbersome regulatory regime when you're not clear on why you're regulating. And so, one of the, I think, I'm very keen to see, and one of the reasons that it can be nimble is if you're always testing it against that purpose. Is it designed to do its purpose? And is that purpose right? And can it properly achieve that purpose? So like I said, protect our environment. Our environment is terribly important to this. We know that. It's a very important part of this country, and we have huge responsibilities to our people as well. And so those things seem sensible to me, to regulate these technologies and make sure that we design a system around it. The system is designed, it's very complex. It took some time to be convinced by those pesky MB officials that such a complex system was required, because I worry about the complexity that it just bamboozles people, and they think that, someone's trying to do one over them by the complexity of it. But, to me, it is because there's trying to be a responsive regulator, which is putting things in the right box and dealing with things and paying attention to the areas where people most care and where the risks need the most scrutiny. And that is the design of the regulatory regime which is before the House at the moment. Like I said, it's difficult. We can see of what's happened, and I guess we look and reflect on how our regulations have worked, and that we haven't had a ban necessarily, but we've had a ban because of the way our culture, our people have responded to the regulations that are in place at the moment, means that they're not really prepared to try and see if they can get through them. It's cost. It's all sorts of other things which prevent people from pushing these technology forward. It's unclear implementation pathway. It's poor investment that people get because they don't know what the outcome of that regulatory process will be. The thing that we need to see is keep our eye on what hasn't allowed us to move forward in this space, so that we don't saddle onto what is supposed to be relatively tight in purpose and driving an appropriate regulatory thing. We don't saddle lots more on to it and then ask it to do everything for everybody, and then be surprised when a regulator gets bogged down in being able to achieve that.
I think that's a really nice way of sort of wrapping up this framework. We have got lots of questions on that regulation, but just really, what are the objectives of it? And it's something that often happens in economic policy, particularly my area, international trade, where it's used for all sorts of other purposes. Come to the America discussion this afternoon. Not what it's necessarily designed for, but this happens, and it's interesting to see that coming through in some of your comments here. Sorry, did you want to?
Yeah, just 2 points. One, on the topic of have there been any issues in terms of GM? Yeah. I think it's really important to remind people that the various studies that have come out, tumours in rats and Indian farmers committing suicide and cows dying in Germany, etc. Not one of those claims has stood up to scientific scrutiny. So that's really important to keep in mind, because you can walk out of this room and go, oh, they said there were no problems, but I see this all over the internet. None of those have stood up to scientific scrutiny. But on the regulation side, there's been assertions in the media that we're going to have the most radical gene technology legislation in the entire world, that we're going to be an outlier. The fact is we are an outlier. We're an outlier because we're incredibly conservative in this area. And when you look at the legislation and you actually compare it to Australia, or you even compare it to the current legislation we have, in some areas we're actually more conservative than the current legislation. For example, there's no ability to deregulate anything. In the current legislation, you can deregulate. A government can deregulate whatever it likes. It would have to face the public music on some things, but under the current bill, under the current law, you can. Under the bill, you can't. There's no such thing as full release in the current legislation, in the current bill, which our current legislation has. And in terms of how far we're moving past Australia, we're not even moving up to Australia in terms of where this regulation sits. So it is a false assertion that we are moving to be on the edge of the world in terms of radical changes.
I think I'm going to pretty soon wrap up the discussion on regulation, because we have so many questions coming through and we understand why that's happening. But I'm just going to ask one last, just for a very brief response, if any of our panellists want to do this. While the panel feels that the risks are low, which I think has come through fairly clearly to our audience, how do we communicate with the public who believe that the risk may be great? I wonder if you just have a brief comment on how we can communicate this better, if you'd like to.
I think it is a challenge that because it's highly technical, some of the advances and what happens, and that adds to the fear of it too. I think there's a real opportunity around providing information and talking much more openly about the technologies, their opportunity, and talking about them within our community. It's like much of science where those advances, some of AI, I think a lot of people talk about AI without even knowing what AI is. I feel that conversation is going on a lot, not really know what it is to take data and to have a learning system from data as well. And so, and we've got that problem around there. But education is important. There's going to be parts of our community, of course, that hold particular views for particular reasons. It's not education. It's related to other views that they have. That it will be hard to change. Yeah.
I think assessment panels and bodies of scientists can help a lot in terms of making the regulatory system much less jumpy. We want it nimble but not jumpy. So when somebody says there's a study somewhere that someone's published, and it may have some alarming risk, or say there's zero risk, what you want really is to assess it over a period of time. To some extent, the climate change world has done this well, but there's a hell of a lot of what we've done that I really wouldn't advise. I don't think we're a model for.
Interesting.
But the basic idea that you really want communities of scientists to play a role in that assessment and communication, I think, is a really good idea. Because the community is stronger together. They represent more like a consensus. It's not like a medical council for an assessment, say the IPCC. The powers of sanction, everything are slightly different. But what they can do is help communicate how the thing works, what the risks are according to the literature, and I think that goes a long way towards making that system nimble but not jumpy, and letting people make informed decisions, both officials and citizens.
Yeah.
I think we've been doing this for at least the last 5 years already. I mean, it makes me nervous when people say we've got to have a conversation about this. I think what we have to have is public have to be able to see individual, tangible examples. So, we've seen in the paper Otago University, looking at using gene drive to get rid of wasps. We've heard about Predator-Free 2050, which is predicated on the fact that we're going to be able to use gene technologies to, drive some of these pests to local extinction. We've heard in the paper about Scion producing sterile pine trees so that we can mitigate the issues of wilding pines. We've heard about ag research developing HME ryegrass so that we can drive down greenhouse gases, or at least methane, increase productivity and reduce, improve water quality. It's when you put those tangible examples in front of the public and it starts to become socialised, that's the education that actually is going to happen. Not getting out there and saying, GM's good or GM's bad, gene technologies or whatever, and having that sort of nebulous NZIR type, one glove fits all. When people actually understand there are real benefits to them and their environment, that's when it makes a real difference. It's the real examples.
And, that's great. Thanks very much, Willie. And that's exactly where I wanted to take the discussion now in terms of the questions, is at that sectoral level. So there's quite a few questions coming through on which sectors are going to gain the most and which components of that sector. Is it the grower? Is it the developer? Is it the consumer? But what I'm going to do is try to frame this question so you can use your particular comparative advantages and strengths and add something in. And I'm going to throw a few little specific questions on sectoral ones that you may or may not care to respond to while you're talking about which sectors are really going to gain. One of the questions was about the agricultural emissions, and Dave, you already mentioned this. The question is it a real game changer? What's the potential New Zealand and internationally for that one? And here's another one that I don't think I heard anyone mention. What are your thoughts on the plastic-eating bacteria? While this is still early research, could this be a real game changer for environmental concerns? And again, I don't know if you have any knowledge in this area, but what I'd like to do is invite each of you to talk about where the gains are really going to come, along with, and I know you did some in your intro already, but let's take this a little further.
I guess those waste stream dealing with, those things I'm really aware of. We will continue in our industrial processes and in our other practices produce waste streams. How do we make sure those waste streams are turned to good? You've probably heard of Lanzatech taking waste streams. Those are genetic engineering tools to be able to use the outputs of waste streams, to be able to use them to make compounds of value. And it's the same, it's the same thing with the plastic degrading enzymes. There's a lot of research. Some of it's going on in New Zealand, by a colleague of mine in my university, but some of it's also going on. There's a lot of exciting thing going on overseas, in the same way that you can engineer microbes to produce insulin. You can also engineer microbes to produce enzymes that chop plastic up. And, we talked about the problem of microplastics. And we also, if you really reflect, as we know when we're looking at the packaging in our environment, how hard that is for us to give away. We're going to have some difficult choices, whether we have technology advanced to change it or we change our practices as well. And this will be tools in the toolbox. I think those things will be real game changers. I think some of it will be developing technologies and being able to develop technologies which are developed elsewhere in the world. And some of it will be the opportunities to take our own science forward.
I think that it'll depend on how broadly things like the methane-related stuff gets taken up. But broadly speaking, because the international world is a voluntary system in terms of environmental regulation, that the UN doesn't levy fines. It's not a government, thankfully, which is a good thing. The role of things like technology is actually really amplified. In a voluntary provision global public goods setting, it's actually the easiest, fastest, most efficient way to provide public goods is through a best shot approach. An example was when DuPont found the alternative to ozone-destroying chemicals in the 80s. So these technological hits, we're finding a new way to do things to deal with plastic waste, to deal with methane's warming effects. There would be good reasons for others to take them up. and then you get all the first mover advantage of being the company of origin for those technologies. DuPont actually played a beautiful self-interested game on that CFC thing, which we could talk about another time, but they basically bullied everybody to use the thing they'd just made. And it's beautiful in a Machiavellian kind of way. I can say that in a room full of economists.
I think one area we haven't really talked about, because I just rattled off most of the ones I know in New Zealand that are going on. I think one of the areas where there's going to be a lot of gain, and where I think the world is really moving, and that's into precision breeding. So the advent of CRISPR-Cas9 of gene editing has actually meant that being able to, I mean, farmers have always, for 9,000 years, farmers have directed evolution at a sort of macro scale by selection. Now we're going to be able to do breeding by direction. And that's really going to revolutionise, particularly in plants, but also in animals. But if you think about plants right at the moment, the way that new plants are developed is essentially exposing them to chemicals or radiation to create thousands of mutations, and then just picking the ones that work, and the plants that died, you don't worry about them. You would never do that to animals, of course. But now you're actually going to be able to write the code in that you actually want and make the changes that you actually want. And that's going to really make breeding very precise. And I think, we haven't talked about the organics industry at all, but I think this is probably the biggest risk for the organics industry, in that they will refuse to use that new technology. And at the moment, the organics industry gets genetic gain through conventional breeding processes, including things like radiation mutagenesis. We're going to just stop using it because it's way too efficient. They're then going to have a problem that they're not going to be able to piggyback on conventional agriculture to have the genetic gain. They will fall behind very quickly. I see that as the biggest risk for organic agriculture. And just in terms of other things that are going on, Plant and Food have a project whereby they turn off the flowering gene, or they actually turn off the flower suppressing gene, so that plants like apple trees will flower within a few months rather than taking 5 years. What they've then done is then bred those conventionally, and then bred the genetically modified bit out, which is now called a null segregant, and it's no longer considered to be a genetically modified plant. And so you've sped up by 5 times your natural development. And it is all about speeding up that genetic gain. But I think that's where there's going to be a big advantage. And may I also say that in animals, that will also be happening. And in medicine, we're already doing that, not in terms of breeding, because that's illegal in another piece of legislation, and so it should be, but being able to fix genes, for example, in haemophilia, so that haemophiliacs no longer have to have transfusions for the rest of their lives. They can start to lead normal lives, fixing these genetic problems. This technology is precise enough for it to be able to be done in one shot. You've only got one shot in medicine to get it right. In animals, you've got more than one shot, because you're not just dealing with one person. But you're going to be able to start to direct that evolution. And I worked on a project, or worked with Lincoln University back in the early 1990s, where they created the very first animal to have an increase in a production trait through genetic modification. They directed IGF-1, a growth hormone, to the wool follicle and got an 8% increase in wool. Now, you might think that's a completely pointless thing to do now, because wool, certainly coarse wool, is worth nothing. But just think, if they had been able to continue that sort of work, even if we'd had no genetically modified sheep on board now, we would understand the genetics of the wool follicle so much better. We'd be able to make wool that people actually want to buy, rather than stuff that sells for less than it costs to take the wool for sheep's back.
Wow. I've just been told that despite our clock there, we've actually only got 2 minutes left, so we can ignore that clock now, and we've got 2 minutes. And I was thinking, I had lots of wrap questions in mind. I was looking at all of this, but you've actually done so much wrapping as we've gone along. What I'm going to do is give you 30 seconds each just to talk about New Zealand in the international environment, because we haven't really touched so much on that. So just 30 seconds, on what are the key issues there.
Yeah, there's a lot going on internationally, and it's important that we look to that international community to benchmark our opportunity. I mean, we learn from the science. Dave said it's important that we're nimble enough to be able to utilise that science and that understanding as we go forward. But, there has been regulatory change in other places. There's proposed regulatory change in others. Most people most of our key trading partners are looking at taking a science-led, technology understood approach on this. I think that is the way to go forward, and I look forward to us being more creative about the opportunities that we might be able to get from some of this technology for this country.
I think we have as a small country that's a small rich country that's actually not embedded in Europe, which is pretty rare. We actually have the opportunity to do some cool things and suggest some good ideas. And people adopt those ideas because they're in their interest. Like our signature move of my lifetime was the Central Bank Act, the independent central bank. We have our rough moments as well as our good moments, and I think the reason I don't think our climate policy at the moment has been very well done. We can persist in doing we're an outlier in terms of how much we're going to buy from overseas. How much we're going to do overseas. We can get caught in groupthink as well as opportunity, and I think that's where openness is a really, really vital part. And I was really encouraged to hear Sir Brian's point on putting citizens and not institutions at the heart of what he's trying to do, because I think that we do have the opportunity to innovate, but we also head down cul-de-sacs sometimes. We have a history of that as well as of innovation. And we need to find ways of avoiding that.
We're a nation of biologists, and we have some of the best agricultural scientists in the world, and we have some of the best medical scientists in the world. And I think the opportunities for this technology is to put us at the forefront of biological science, and to put us at the forefront of being custodians of the environment and solving and at least mitigating, because I never say these problems are solved, but solving the problems, mitigating the problems, the environmental problems we have. If we can attack some of these problems using whatever tools we have, but have all the tools at our disposal, then we can actually be world leaders and add value to our products by being better for the environment, for our people, and also for our economy.
And isn't that the perfect note to end the discussion on?